Hey everyone, welcome to Learner's Tree. Hope you all are fine. And here I am with a new video. And in this video, we are gonna go through the basics of naming of organic compounds, which is kind of a nightmare for the students of SSC and HSC level. But I will try my best to make it easy. Okay, let's see. So the basic of naming of organic chemistry is understood by learning the naming of alkane. If you can name alkanes completely, then I promise you, you'll be able to easily name any other organic compounds with a bit of modification. So let's see and try to understand how we should name alkanes. So for naming an organic compound, the IUPAC is an international organization which has set us some rules. So people generally first go through those rules, try to memorize them, and tries to name the organic compounds by using those rules. But we are not going to do that. We are going to see examples and validate those rules. So first of all, I have just written three basic rules for naming alkane. That is, find the longest chain, parent chain would be the longest chain, and find the site from which substituent groups have lower numbers. So I don't want you to understand these rules, but once we solve these four examples, these rules would be clear. So let's do it. In case of first one, we have a 1, 2, 3, 4. 4 carbon based alkane. So we know if we have a 4 carbon based alkane, then it's butane. So this would be butane, no doubt about that. But we here have a substituent group. And the first step of naming was find the longest chain. And that's what I did. 1, 2, 3, 4 carbons. And if I number the carbons from here, then I will also have 1, 2, 3, 4 carbons. Clear? So it's butane from either side. Then the parent chain is longest chain. As I identified the longest chain, I immediately say that it's butane. So the compound's name or the parent name would be butane, since the longest chain is always the parent chain. Then we will have to find the site from which substituent groups have lower number. Let's see, if we number this long chain from the left side, then we have this serial. So this carbon is the number 1 carbon, then we have this one as number 2, 3 and 4. And if we number the carbons from right to left, then we have 1, 2, 3, 4. So if we number the carbon from left to right, then the substituent group falls at number 2 carbon. But if we name it from right to left, then as we can see, it falls at number 3 carbon. And what the rule says, we'll have to number the carbons from the side which has lowest number for the substituent group. So we will number it from left to right. So the name of this compound would be 2-methyl butane. Clear? I have named this from left side since the substituent group, if numbered from the left side, falls on second carbon, and these are basically alkyl groups. I think you guys know what alkyl groups are. When we remove a hydrogen from alkane, then the part that we are left with is called alkyl group. Here, this one is a derivative of methane. That is, one hydrogen from methane is removed and one arm of the carbon is freed. That's why this one is called methyl. But if ethane gave one hydrogen away and formed bond with another carbon, then that group would have been ethyl, since it comes from ethane. Clear? So the name of this compound is 2-methyl butane. Okay, now let's name this one. This and this is completely same, except it has a extra methyl group. So if we name it from this side, number it from this side, then the number would be 1, 2, 3, 4. But if we number it from the left side, it will have 1, 2, 3, 4. So in both cases, the substituent groups are falling at number 2 and number 3 carbon. So we can name it from any side as we like. So this one would be termed as 2, 3. How many methyls do we have? 2 methyls. So we will have to write it as 2,3-dimethyl butane. Clear? Now, in this case, we have a methyl group and a ethyl group. So, by now we know the rules of naming alkane. So, first step is identifying the longest chain. Let's identify the longest chain. Here, if we number it, if we consider this one as the longest chain, then we will have 1, 2, 3, 4 carbons. But if we consider this one as the longest chain, then we are going to have 1, 2, 3, 4, 5 carbons. That is, if I expand this structure here, it would be something like this. So this one is our longest chain, and as the second rule states, the parent chain is always the longest chain. So this compound would be a derivative of pentane. That is, the longest chain is 5 carbon based, and that is why the compound would be pentane. Now let's number it and see from which side we should number. If we number it from this side, then we will have 1, 2, 3, 4 and 5. We are having a methyl group at number 3 carbon and another methyl group at number 4 carbon. But if we number it from this side, then we will have 1, 2, 3, 4 and 5. In that case, we are having a methyl group at number 2 carbon and another methyl group at number 3 carbon. So in this type of cases where we have multiple substituent groups, we'll have to consider the least sum. And what I mean by that is, if I number this compound from this side, then I have my substituent groups at 1, 2, 3. So 3, and the next substituent group is at 4th carbon. So 3 plus 4 gives me 7. But if I number the compound from this side, then I have 1, 2. At number 2 I have a methyl group, and at 3 I have another methyl group. See that? So if I number it from right to left, I have the summation of the substituent groups as 2 plus 3 equal to 5. So I will number it from this side, as it gives me lowest number in case of substituent groups. So this can be named as 2,3-dimethyl pentane. Clear? Okay, now let's see this example. In this example, we have a ethyl group, a methyl group, and a bromine attached to the main chain as substituent groups. So first of all, as before, we'll have to identify the longest chain, and the longest chain contains 1, 2, 3, 4, 5, 6 carbons. If we try to number the carbons from this side, then we have 1, 2, 3, 4, 5, 6. In either way, we have 6 carbons. So let me consider this one as the longest chain. Okay, now if I try to number the substituent groups, let's see from which side I'll have to number. If I number it from left to right, I have 1, 2, 3, 4, 5, 6. So the substituent groups are falling at number 3 carbon and at number 5 carbon. So I have 3 plus 3 plus 5, which gives me 11 if I number from left to right. I have written 3 twice, since at number 3 carbon I have 2 substituent groups, and at number 5 carbon I have only a single substituent group. But if I number it from right to left, then let's see what I have. 1, 2, 3, 4, 5, and 6. So if I number it from right to left, then what I have is 2 substituent groups at 4th carbon, that is 4 plus 4, and a single substituent group at 2nd carbon. So this one is 4 plus 4 plus 2 equal to 10. So I'll have to number it from right to left. If I number it from left to right, it would be wrong. Clear? So if I number it from right to left, then I will name it as 2 bromo 4 ethyl 4 methyl 4 methyl hexane. Okay, now you might wonder, why did I write bromo first, then ethyl, then methyl? The answer to this question lies in the first letter of the substituent group, and the order would be alphabetically. What I mean by that is, the first letter of bromo is B. B comes before E. So I have written bromo in the beginning. Then I'm left with ethyl and methyl. E comes before M. So ethyl has been written first. And for that, methyl has been written at the last. And thus the name is 2 bromo 4 ethyl 4 methyl hexane. Clear? Now we will see some more complex examples to make our idea concrete. Okay, now we have 2 complex examples, and I promise if you can name these 2 organic compounds successfully, then you can name any alkanes. So let's see how we can name these things. Okay, first of all, this one. And as we know, the first job is to find the longest unbroken chain. So let's see which one is the longest chain. So if we consider this straight chain as the longest chain, we will have 1, 2, 3, 4, 5, 6, 7, 8 carbons. But if we consider this one as the longest chain, then let's see what will we have. 1, 2, 3, 4, 5, 6, 7, 8 and 9, since there are 2 carbons here. So this one would be the longest chain. If I break this one, this would be something like this. Clear? So I have my longest chain, which is this one, a 9 carbon based organic compound. Okay, now my second job is to number the main chain from the side, which will give me least sum for substituent groups. So if I number it from this side, then I have 1, 2, 3, 4, 5, 6, 7, 8 and 9. So in this case, I have 2 methyl groups at number 2 carbon. So the sums are 2 plus 2. Then another ethyl and methyl group at 4th carbon. 4 plus 4. And at number 6, we have another methyl group, that is plus 6. And again at number 7, we have this methyl group. So if I number it from right to left, I have 2 plus 2, 4, 8, 12, 18 and 7, that is 25. But if I number it from this side, then let's see what I have. This is number 1, 2, 3, 4. Sorry, I think this is kind of confusing. Let's write 4 here. 5, 6, 7, 8 and 9. In this case, I am having the first substituent group at 3rd carbon. This is the number 3 carbon. So 3. Then the second one at 4th carbon plus 4 plus I have 2 at 6th carbon plus 6 plus 6 and 2 at 8th carbon. So the summation would be 3 plus 4 7, 6 6 12, 12 plus 7 19, then 27 and 35. So this is obviously greater, and hence I have to select the least one. So I'll have to number it from right to left. Clear? Now I have identified the longest chain and I know from which side I'll have to number. So I will just write down the substituent groups in alphabetical orders. So I only have a single ethyl group that falls at 4th carbon. So this would be 4-ethyl. Then I have many methyl groups. Let's see how many methyl groups I have. 1, 2, 3, 4, 5. 5 methyl groups at, let's see which carbons. So 2, 2, 2, 2. Then I have another methyl at 4. Then my next methyl is at number 6. And another methyl at number 7. So 2, 2, 4, 6, 7 pentamethyl nonane. 9 carbon based alkanes are termed as nonane. Clear? Okay, now let's see another example. In this example, we have our halogen groups. So in this case, if I number the alkenes or number the carbons from this side, I will have, first of all, let me identify the longest chain. So 1, 2, 3, 4, 5, 6, 7, 8. This one would be the longest chain. If I consider this one, then let's see 1, 2, 3, 4, 5, 6, 7, 8. So either way, we have 8 carbons as the longest chain. So I will consider the straight one to be the longest chain. Let's see, if I number it from this side, I have 1, 2, 3, 4, 5, 6, 7, 8. But if I number it from this side, then the numbers would be 1, 2, 3, 4, 5, 6, 7, and 8. So let's see where my substituent groups fall. If I number it from this side, then I have a substituent group, two substituent groups at 2nd carbon. So 2 plus 2, and 1 at 4th carbon, and 1 at 3rd carbon. So 3 plus 4. Then I have 1 at 6th carbon and another at 7th carbon. So the summation would be 2, 2, 4, 7, 11, 17, and 7, 24. But if I number it from this side, then I have 1 at 3, then another one at number 5, then another one, sorry, I missed one here, so a 2, then the next one I will have at 6, and 2 at 7. So in this case, the number would be 3 plus 5, 8, 10, 16, then 7 would give me 23 and 30. So I will take this numbering, and for that I had numbered it from left to right. So the name of this compound would be something something octane, since it has 8 carbon. So first I will have to see the alphabetical order. Here I have the bromine. So B comes before C. So I'll have to number, or I'll have to name bromo first, and then I'll have to go for chlorine. Then I have ethyl and also a fluorine group. So E comes before F. So thirdly I'll have to number or name ethyl. So let me do that. 2 bromo. Then I have my chlorine at 6th carbon. So 6 chloro. Then I have my ethyl at third carbon. 3-ethyl. Then fluorine at third, or I must say second carbon. 2-fluoro. Then I have a propyl and a methyl. So 7-methyl. Then I have a propyl group at 4. 4-propyl. 4-propyl. And the main compound is octane. 4-propyl octane. So these are basically the rules of naming alkane. And as I said, if you can name alkanes properly, I assure you, you can name any other organic compounds. So I would suggest you to see this video more than once, because if you see it once, there might be some confusion. If you see it twice or thrice, I hope it would be clear. But still, if you have any questions, you can ask me in the comment section and I will try my best to solve that. And you may put some structures of alkane in the comment section, or post a photo of alkane in the comment section if you guys can't name that, and I'll try my best to help you guys. Okay, thank you.